master all this stuff. More than that. All right, so welcome back. This is approximately 3.1.2. Okay. Looking at the unit circle. The unit circle. The thing with the unit circle is it's a very special case. It has very special parameters on where it's located, how far each of these spokes, these radii, how far the radius extends. First off, we'll just start. Where is this point?
0, 0.
0, 0. What do we call that again? The origin. The origin is in the middle. Yes, yes. So we'll go ahead and just put 0, 0. It's key that it's right in the middle. Okay. The unit circle is always set up like this. We always set up here because we can deduce all the information about the angles from the fact that it's 0, 0. And then the clue is, in the name, what else is something that is very fundamental to this circle? Units. How many units? One unit. 1 unit. So the spokes of this wheel are 1 and 1 and 1 and 1. Right? The radius here, the radius is 1. So if I'm going from my origin, from the very center of my graph, I'm going to the right 1 along my x-axis, what point do I end up with over here? How far as far as x goes, x we move over 1. As far as y's, do we go up or down at all? No. 0, 1. 0, 1. Oh, sorry, 1, 0. Just like the stop. All right, so we can, since we know this is 1 and that's 1 and that's 1, we can find our 4 ordered pairs that are on these main corners. Right? So I want you to go ahead and think about it this way. I'll help you with this one up here. How far along x and y do we go in order to end up aligned right there? We're starting here. Do we go left or right at all? No. So my x here is at 0 because it's no change along x. But how far up do I go? 1. You see how the unit circle makes it's totally clear. I know for sure. It's 1 up, so it's 0, 1. In this case, it's 0, 1. You see how this is breaking it down? And we'll break all the other spokes off, and you'll see the patterns for each.
Oh,
yeah, we're getting there. Oh, we're getting there. Well, we're going to start to touch on that on each of these different points. And as we build them, we'll see that over and over. Okay. What's this? Somebody help me out. -1. How many up or down? How far up or down? 0. It doesn't deviate at all from the x-axis. How about down here? 0, -1. Is everyone okay with finding these? Okay. And it's the same process. It gets slightly more complicated. But let's look at now. We know that it starts at 0, 0 in the middle. We have the points, our main points at each of the corners. And now I want you to think back. Right? I want you to think back. If I start and go around a circle, how many degrees to go all the way around? 360. And someone remind me, what is the circumference formula? C is equal to 2 pi r. Now here's the deal. The reason why my radians make sense on this circle is, what is my radius for any place here on the unit circle? My radius is 1. It's 1 from here to here. It's 1 from here to here. 1 from here to here, right? So essentially, I know my circumference all the way around the circle. As far as radians go, my hint is that there's pi in here. 2 pi times 1. What's my circumference? 2 pi. So I know that my radian measures, if I start here, this is always the starting place. You always start here and move up. If I start there and go all the way around the circle, as far as radians go, I've gone 2 pi radians. I've rotated around 2 pi because this distance around is my circumference, and with a radius of 1, I get a circumference of 2 pi. Does this part right here at least make sense? Right here? Radius is 1, circumference is 2 pi r, so I get 2 pi as my circumference. So I could say, yes, if I'm talking about radians, which radians is a measure that includes pi, it's not degrees, it goes 2 pi to go all the way around. Okay. Does that make sense? I don't feel like it. Yes.
So what if radius is not 1, or is it always 1?
Right. Unit circle, we can always 100% count on it being 1.
Okay.
It's a contrived kind of setup situation to devise all this from. So it's nice that it's 1. You'll see why it's nice it's 1. So if I'm right here, okay, and I'm talking about radians. How many radians have I gone? Remember, this is always our starting point. How many radians have I gone if I'm still on the initial line? 0. 0. How about if I rotate from this initial side, rotate all the way around to get all the way back to the initial side? How far have I rotated around with radians? How far? Almost. What was the circumference if you go all the way around the circle in radians? Not degrees. Give me in radians. 2 pi. So if I rotate all the way around, here's 0 for radians. I go all the way around. I've gone 2 pi radians. Watch. I'm going to say this is 0. This is 2 pi. 0 degrees, haven't moved from the initial. I go around an entire circumference, entire rotation in radians. I get 2 pi. If I run around another time, 2 times around, I get to 4 pi. If I go around another one, I get to 6 pi. It keeps adding on like that, though we're only going to deal with it likely just within one rotation. Just trying to point out that it just keeps adding up as you go around. Okay? Just like 360, you go around 360, you go around again at 720, you go around again 1080, so on. All right, is everyone okay with how I got these two here? Pretty good? Okay, so if I go all the way around, it's 2 pi. How about if I go halfway around? Halfway around? Pi. This measurement right here, our theta is pi. And I'll just write it, radians. So here's the thing. Here's 0. Here is pi. Between 0 and pi, how would we find this point? What would this angle be? Half a pi. Pi over 2. 0 pi. Half a pi. An entire pi. Okay? 0, 50-cent piece, $1. Another 50-cent piece gets me where? 1.5, right? If I express it still in halves, I have 3 halves. 3 half dollars, $1.50. So here's 0, here's half a pi, here's a full pi, here's 3 halves. Now, don't worry if it would be really hard for you to figure out that that's 3 pi over 2. Once we do this once, we're going to be able to access and reference it and just teaching it, right? So just know that's how I'm forming this. Okay, if this was all we had for the unit circle, how would you feel? Thumbs up, sideways, down for this. For this? You get it? Okay. There's only a couple of things we're going to do. We're going to break these guys one more time. Go ahead and make a next line in here. If you want, you could even make a whole new circle, and we're going to do the fourths, whatever you want to do. Right. Okay? So looking at this, all I did was break those quadrants, the 4 that we had up here. I just broke them in half. Now looking at this, here's 0. This is 0. If my theta opens up to straight up and down here, I'm at pi over 2. Pi, half of a pi. So what would be between 0 and a half? What would this be? Pi over 4. Intuitive? You see it? That was a lot. Pi over 4. Okay? We have 0. We have a quarter. We have half. What would this one be? Think of like quarters, like money. 0, you got 1 quarter, you got 2 quarters, 50 cents. 3 quarters. There it is. Okay. Building, building, building. Taki. 3 pi over 4, 3/4, $1, 1 pi. If you have $1 and you add a quarter to that, how many quarters would you have? 5 quarters. 5 pi over 4. See where we're going? So let's look at it again. 0. I got 1/4, 2 quarters, 3 quarters, 4 quarters, that's $1. 1 more quarter, 5 quarters. 6 quarters, think about that. 6 over 4 reduces to what? 6 over 4 reduces to? 3 over 2. So that makes sense. That's another quarter. Okay. So this is essentially 6 quarters. What's this one then going to be? 7 quarters. What's this then? If this is 7 quarters, 1 more quarter gets you? 8 quarters is equivalent to 8 over 4. 8 over 4? 2 pi. You see how it builds? Seeing it now? A little bit. Okay. So there were 3 things I wanted to really find today. We're figuring out the thetas. We're going to find our reference angle, which helps us graph from scratch. And we're going to find the coordinates. That's all we have to do to get caught up. That's the essence of yesterday and Monday. Okay. So I want to look at, for these right here, I want to look at my reference angles to start. I'm going to start looking at reference angles. So let's look at this. I want you to write this in the notes. A reference angle is the radian measure. Whoops, that's not even. The radian measure to get to the x-axis. I'm trying to find the closest way you can get to the x-axis. So here's my x-axis. X-axis. So if I'm at pi over 4, right here, what is the closest x-axis from there? If I'm here at pi over 4, should I try to figure out this? What's the closest one? From here? That. See? That. So what is this angle? This one's easy to figure out. If I had pi over 4 to get up, then how about to go back down? Pi over 4. The reference angle, again, is just to help you graph. It's just to help you graph. That one's not useful in that case. But let's jump over to this one. So if I have to graph 3 pi over 4, it's harder to visualize 3 pi over 4. How far do I go? I'm not sure. It's easier to think about, well, to go all the way down to the x-axis is another pi over 4. 3 pi over 4 plus another fourth gets you $1. Okay. So it's easier to think, I'm going to graph this line. If I just had to graph this from scratch, it would be around here. But the easiest way for me to figure that out is actually in my head think, what was my reference angle? It's pi over 4, so I just needed to go up pi over 4. And that gets me to my theta of 3 pi over 4. It's just a way to look at, okay, in relation to the x-axis, how far up or down do I need to go? It's a very simple tool just to be able to graph it easily. Because remember, here, this is theta. I'm looking for my theta, which I was given as 3 pi over 4. So instead of thinking, well, where does 3 pi over 4 land? I know this is pi, but where does it land? It's easier to think of this reference angle. I know that it's pi over 4 to get down to the x-axis. Everything is rotational, remember. Everything we're rotating here. Blake?
Oh, what's the angle on the right side?
Where?
The green one on the right.
Pi over 4.
Oh, just pi over 4?
Mm-hmm. Yeah, it's not written clearly. So we know that this is, right? We have 5 quarters. How far to get back to 1? 1 quarter. You can see a pattern that's happening here, right? Those are my reference angles. I think that I'm going to go to our third point here, doing some coordinates, and then I'll go a little deeper into our other spokes. Okay, so to find our coordinates, it's actually not so bad. Because I know right here, theta is equal to pi over 4. Right? Theta is equal to pi over 4. So this ordered pair out here, we're going to have an x and a y value. The way that I figure out what is my x value right here, so this is a point, right? In relation to the center, where is this point? What you can do is you can take the cosine of theta. That would give you your x-axis, your x value. And then you take the sine of theta to get your y value. I think tomorrow I'll actually break that down, explain that further, but I want you to use it as a tool right now because we're just building it all. Okay. So go ahead and get out your calculators. I want you to try this, or on your phone. The cosine of pi over 4. And if you have an iPhone, you have to put in pi over 4 and then push cosine. Okay? So the iPhone does it backwards. Otherwise, you just push the cosine button. In the parentheses, you use the pi button over 4, and that's going to give you some value. And so find the cosine of pi over 4, then find the sine of pi over 4. That'll give you your x and your y. Yeah? You see it now? Okay. And again, it might feel like you got it, and then you don't have it, then you got it. So just keep coming back to it. There's some fundamentals you got to remember about this. You just got to repeat it. All right, let's see. Connor, what is my x value right here?
The x value is negative 0.65.
Not quite. Why do I know that it's not negative for my x value here? Because here's the origin. I'm going positive direction over. So that is going to be a positive value. So Stanley, what do you have for me?
Is it 0.7071?
0.7071. We're going to get used to that.
Oh, yeah, that's right.
Right?
Yeah.
That's root 2 over 2. If you kept them in roots. A lot of you are going to use decimals. That's fine. What is the sine value for that? Sine value? Same. Good, Sterling. So it's the same, and let's look at why that might be. Think about it this with me, and this is kind of why this works out. Here's 0 degrees, here's 90 degrees, so halfway in between. What degree value would this be? 45. Essentially what we have is a triangle that is a 45, 45, 90. So I know that these two sides of an isosceles triangle have to be the same. Okay, that's just like a side point. If that went over your head, don't worry about it. I don't mind if you just use trig functions for this. All right, so let's look at, maybe we can figure out the rest of this from that information. If I'm trying to find this point up here, first off, think about it. Is it the same y gain in our y here? These are even, right? So I can see here that you could do the sine of 3 pi over 4, but because my y values here and here are even, it's going to be 0.7071 for my y value. Because it went up the same amount. And then go ahead and do the cosine of 3 pi over 4. It would for the x value because that is going left, but it's y, right? Going up.
That's to be a reading, right?
Good. So you did see that part in. Double check if you're not getting those answers. Go ahead and put your calculator in radian mode. You can do it on an iPhone too. Yeah. Okay, Jared, what'd you get for my x value here? From this, yes, Trinity. Undid what? On the iPhone? Yeah, are you ready? Yes. Starting to feel it? Yes. Good, good. Keep going. I might break this lesson into 2 days. We'll see. I'm going to try to stop at noon and let you work on some others. Other of these. All right, let's look at this one. Find this point here for 5 pi over 4. Connor, what do you think?
I got for the x, I got negative 0.771.
Let's see if that makes sense. Do we go over the same value as far as x's go to be at these 2 points? Yes. If it was a perfect circle, you'd see it clearly. And then how far down did we have to go? Negative how many? Okay. So you see if you're doing all the fourths, there's a pattern. I want you then to find this last one. You can do it by a pattern. You see the pattern? Oh, that other try for a sec. So we knew this was negative 0.7071. And you could have just said, well, I know that because I take the cosine of 5 pi over 4. Or you can know that all these quarters are aligned in a way that I'm going, as far as x goes, I'm going over even with these 2 points, and I already found that point. That's why that translates. I'm going down negative 0.7071. So sometimes you don't have to do the trig to find the point. But this last one, we can intuitively, we don't have to use any trig. Let's intuitively figure this one out. As far as x goes, how far over? Is it positive or to go this way and next? Positive. 0.7071. How far down do I go? Negative 0.7071. Just works out. Okay. Thumbs up, sideways down if this was the entire unit circle. Okay. Sideways. Yeah. Yeah. There's going to be some topics. I hate Ramian sums. When you get to second level calculus in college, Ramian sums, hate them. I don't like it. So don't worry. I mean, even within a subject, there's things you like or don't like. If you're thumb sideways, even if it stays thumb sideways, you can still build that up a little bit. Okay. So, yeah, let's go a little deeper. I'm going to put up the thetas for the next level that we're going to look at, and from there I'll have you do the last bits of it and fill in that worksheet. Start to fill it in. Okay. So I'm just going to erase this a bit. You guys are doing great. A lot of focus in here. It's an easy. All right, here we go. All right. The next way we're going to divide this up is to divide this semicircle from here, the initial side, to pi. We're going to break that up into 6 parts. Watch. So there's going to be 3 here. There's going to be 3 here. That's how I would do it, and then just kind of have those extend out the other side. See, we got 6 parts. So if I were to keep that quarter, the regular, like what you have on the worksheet, it just has this as well. It has these quarters put in there as well. Okay. But there's 2 ways to break it up. Basically, is to break the whole circle into 12 parts, or I think of it as 3, 3, 3, 3. We just did the red lines here, so I'm going to erase them. But the red lines that we did was the quarter marks. Here's 1, here's a quarter, here's a half, here's 3/4, here's 1. Right. The red ones here are quarter marks. The green ones I just put up are going to be our segments here into 12 parts. So there's 12 parts here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. All right. But looking closely, here's 0. Here's 1 pi. Right? 1 pi. So if I'm going to be adding up between 0 and pi, there's 1, 2, 3, 4, 5, 6 parts here. So watch. This one is theta is equal to pi over 6. You see? I just broke it up into 6 parts. How many 6 do I have here? Here's 1 6. Here's 2 6. Reduce 2 over 6 to what? Here my theta equals pi over 3. You can think of that, well, that's really just 2 pi over 6, which would be the next sixth we have to go up. This reduces to 1/3. That's why I put that there. All right. And what would we have next? Where? Okay, pi. So this is 1 6, 2 6, 3 6 is a half. I know. I'm throwing fractions around really quick. So here was 3 6. Then what's this going to be? 4 6. So let's just put it up here. 4 pi over 6 reduces to be 2 pi over 3. So we had the 4 6. What's this? 4 6, 5 6. Hey, this day is like a 9, so don't worry if it's like, I don't like it. Take my jacket off. All right. 5 6, 6 6, 6 over 6 is 1. What's this?
7.
Okay. 7 6. 8 6, let's put that out here and reduce it. 8 pi over 6 reduces to what? 4 thirds. You know, the 3's that you see, the thirds, are just reduced sixths. So all we have is our halves, we have the quarters, and now we have it broken up into 12 parts here. Those are the 3 things. Oh, yeah, I know. Jordan. It's me. 4, let's see, this was 8 6, 9 6, which is 3 halves, 9 6. What's next? 10 6. Reduce that for me. 5 thirds. 5 pi over 3. So this was 10 6. Then what's this? 11 6. This combined with what we did with, this combined with what we did with the quarters is all of our thetas we have to deal with. So that's good, right? That's good. Not bad. The inverse of bad, to some degree. Here's what I want you to do for the last 25 minutes. You can work with a partner because this is going to be tricky. Don't reference a unit circle at the back of the workbook or on your phone. That's useless for this. Really wrestle with this a little bit. I want you to find, we know the thetas, right? We know thetas. So that's done. Now I want you to find our reference angle. Our reference angle. And I'll give you a hint for this. The reference angle is always your theta. Does that always work? One sec. That doesn't quite always work. Reference angle. So we're thinking of the radians to get to the x-axis. And then I want you to find the coordinates. So you can start to fill in the worksheet. Fill in the worksheet. Everybody peek at the worksheet real quick. So you see how, look at the first quadrant up here. So the top right. You see how there's 3 lines in a row? Imagine taking out that center line. If you take out the center line, if that's not there at all, then you have 1, 2, 3. You see? So the center line, those are our quarters. Everything else is what we have up here on the board. So just how to navigate it. You see the top quadrant? That middle line, if you take that out, that was our quarter. the middle line, I'm just trying to distinguish. Before we did this, remember we had in red? Those red lines we had before are those middle lines. Everything else, if you took those out, is what you see here. So essentially it's like this. Here's our quarters, right? So you can start to input information on that, but really what we're going to go for right now is these right here, these main radians. I want you to find the reference angle for it and the coordinates. Okay? Coordinates, it's just cosine of theta, sine of theta. So that's your goal for the rest of the period here. All right, give me the thumbs up, sideways, down now. Thumbs up, sideways, down, full thing. Done all right? Okay, okay. All right, there's no thumbs down. Wait.
No, it's like right here.
It's here, though.
Yeah.
Okay.
It's a little bit.
It's just the thumb moving?
It's okay, I'll talk to you.
All right, guys. All right, don't forget to subscribe, but nobody does that anymore, but it's okay. Come on, subscribe. All right.